Hello and welcome to this episode of Math with Martinez. In today's video, we are looking at wanting to solve systems of two or more linear inequalities. And so that's what we've got here, a couple steps that we're going to be following in order to solve our systems of linear inequalities. So like it says here at the top, the solution to a system of linear inequalities is going to be the set of ordered pairs that satisfy all the linear inequalities. And the solution can be shown by graphing. So let's look at these steps. Pretty short and sweet. First step, just to graph and shade each of the linear inequalities. And then step number 2, where that solution region is, the solution to our system is where the shading overlaps. I'm going to show you guys what that looks like here in this very first example. So here we go. I'm going to do this first inequality in one color, and I'd encourage you all to do the same, and the second one in a different color. This first one I'll do in orange. So we've got the inequality y less than or equal to negative 2 over 3x and then minus 1. So for that inequality, let's find the b and the m so that we can graph. I'm going back to what we saw yesterday. In order to graph just a linear inequality, you want to begin by making sure it's in slope-intercept form and then graphing that line. So our b value, where we begin this graphing, is at negative 1. So I'll plot that point on my y-intercept as my y-intercept. And then our m is a negative 2 over 3. That's how we move. That means I'll go down 2 over to the right 3. Down 2 to the right 3. Or I could go up 2 and left 3. Up 2 and left 3. That is now the kind of structure. Now, based on the little symbol that we have here, because it is a less than and equal to, that little solid line underneath means it's going to be a solid line. So I'll connect those points with a solid line. Oh, that line was pretty terrible. Let me try again. That was a lot better. And then, because it is less than or equal to, we will shade below that line. So I'm going to go ahead and shade below that line. And you're going to notice here that I will always completely graph one inequality before I graph my second inequality, including the shading. Do all the steps like we saw before you then begin on your second inequality. So now I'm going to graph my second inequality. I'm going to begin with my b value. What's the b value for that blue graph? It is a negative 8, so I'm going to begin at negative 8, which is way down here, right at the bottom of that coordinate plane. And our m is 1 over 2. So that looks like going up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2. Now, because that symbol is a greater than or equal to that little line underneath, means it's going to be solid line. And because it is a greater than or equal to, we're going to shade above. Greater than or equal to. We got to shade above that blue line. So above that blue line is going to be all of this region here. So now that we've done part 1 and we have graphed and shaded each of our linear inequalities, now let's move on to step number 2. The solution region is where that shading is overlapping. So where do the orange and the blue overlap? That's going to be right in here. I'm going to put a big S for solution. That is my solution region. Meaning any coordinate anywhere in here in this area that has been double shaded, any point that I were to pick in this region will make both of those inequalities true, and therefore it is a solution to our system. But if I picked any points over here, or here, or here, none of these points make both of them true. So it is not a solution to the system. All right, ladies and gentlemen, so that was one example. Let's look at another here. Let's look at example number 3. We'll look here at this first inequality. Now, like we saw yesterday, to be able to graph that inequality, it must be in slope-intercept form. So we need to get this in slope-intercept form. I need to go ahead and rewrite this. I would need to subtract x on both sides, giving us negative y greater than or equal to negative x plus 1. Then to get y by itself, we have to divide everything by a negative 1. In doing so, we will have y less than, don't forget to change that sign, right? Negative divided by a negative is positive x, and then minus 1. Let's write our beginning value and our slope value here. We will begin at negative 1, that is our y-intercept, and then we will move 1 is our slope, or 1 over 1. So we'll just go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, just like so. Now, based on that sign, it is what kind of line, you guys? What kind of line does this inequality sign mean we'll have? It is a dashed line. So we have our little dashed line continuing in this fashion. Make sure you take up the whole coordinate plane. And because it is a less than symbol, we're going to shade below. So we'll shade here in the region below. One inequality has graphed. Now let's try the other. Again, we need to rewrite this so that it is in the appropriate form. Right now, it is not in a form where we can easily graph. I'd want to subtract x on each side, which gives me 4y greater than a negative x plus the 20, and then divide every term by 4. Doing so will give me a negative 1/4 x, and dividing 20 by 4 is 5. So what is our beginning value for this graph? That beginning value is at 5 on our y-axis. And our manner in which we move is going to be a negative 1/4, where the rise is negative 1 and the run is 4. That means that we're going to need to go down 1 over 4, down 1 over 4, or up 1, left 4, up 1, left 4. Our symbol is a greater than symbol, so our line will be dashed. Our line here will be dashed. Let's connect those points with a nice dashed line. And because it is a greater than, we're going to be shading above that line. So that looks like shading this region here. So now the solution is going to be where the shading overlaps. Where does our shading overlap? That's going to be in this little section here that is in the corner where the blue and the orange are overlapping. All right, ladies and gentlemen, I want to challenge you all to try problem number 5 on your own. Go ahead and pause the video and see if you can graph that system.